Hello students and welcome to Solving Absolute Value Inequalities. This is on the back of the second page of solving equations. It's on the back of this right here. So first, what's an inequality anyway? So if I were to say the absolute value of x is greater than 5, that means for what values of x will the absolute value of x be greater than 5? So let me just draw it because that'll make more sense. So here's my absolute value parent function. Not very well drawn, but it's there in spirit. So there's the absolute value of x. So I want to know, when is that going to be greater than 5? So here's 5. 1, 2, 3, 4, 5. I know these are labeled a little funny, like on top of the line instead of on the line. So here's 5. I don't want my absolute value to be equal to 5, just greater than 5. So I kind of shaded above. So now I can see right here, that's where it starts. Right there. So I know if x is greater than 5, or that way, or if x is less than negative 5, then I know my absolute values are going to be bigger than 5. So I would write that like x is less than negative 5 or x is greater than 5. So basically it involves multiple solutions. So likewise, let's say I want to look at the less than 5 part. So there's my absolute value function right there. Let me find where it's 5 again. Less than 5 is going to be this way. So less than 5 is in here. So notice that my line goes through there between negative 5 and 5. So for greater than, I was kind of negative 5 to that end and positive 5 to that end. Now I'm between negative 5 and positive 5 is where my line is. So negative 5 is less than x is less than 5 for that one. Now, you probably don't want to do all these problems by drawing graphs. So we're going to be solving them algebraically, and it's actually a lot like this. There's just one extra thing you need to do when you split your problem. But if you kind of understood this, then you're going to understand this too. So let's try solving some of these. You solve these the same way as the previous lesson. Except when you make the constant negative, you flip the inequality sign. So I'll show you what I mean by that. So let's start with this one. The absolute value of x is less than or equal to 3. So let's go ahead and split that. I know I'm going to have x is less than or equal to 3. And the other one, before I would have written x is equal to negative 3. This time, since I have an inequality, I'm going to flip that sign. That's because the negative numbers are the mirror image of the positive numbers, so you have to go the other direction. And there is my solution. And I can also write this as negative 3 less than or equal to x less than or equal to 3. Number 2. Again, I'm going to split it. X is greater than or equal to 1.5. So that kind of stayed the same. But when I split it and make this negative, then I'm going to flip that inequality sign. So x is less than or equal to negative 1.5, or x is greater than or equal to 1.5. And there's my solution. Now number 3, the absolute value of x is less than 0. Now there's a bit of a trick here, because if I go less than 0, so let's see, here's 0. If I go less than 0, what kind of numbers are these? These are negative numbers. And remember, absolute values can't be negative. So by saying when is the absolute value less than 0, I'm really asking when is the absolute value going to be negative, and it's never going to be negative. So this is going to be no solution. Number 4, we got another special one. Absolute value is greater than -7. Let's draw that again. -7. And there's 0. Okay, so they want to know when is the absolute value number going to be greater than -7. So remember, absolute values are always positive or 0. So it's basically asking which positive numbers, so positive or 0. So it's wanting to know when are positive numbers or 0 greater than -7, and the answer is always. So this one is going to be all real numbers. So you try number 5, think about what we talk about right there, and see what you think. Good, so hopefully you got no solution. Since absolute values are positive or 0, they can't ever be less than or equal to -2, so no solution. And finally, go ahead and give number 6 a try. Number 6 is a lot like these two. And that's what you should have gotten for number 6. X is greater than 2/5, so that pretty much stayed the same. And then x is less than -2/5, the sign flips. So here's probably what you might be thinking as you get into this. When is your solution going to be all real numbers? So basically, if your equation looks like this, like if I have x, and I can have other things inside here too, but if the absolute value is greater than 0, or the absolute value is greater than or equal to 0, then my solution is going to be all real numbers. Then for no solution, if your equation looks like this, or if it looks like one of these, so it could be equal to 0, that's okay, but you don't want to be less than or equal to a negative, and you can't be less than 0. Then you're going to have no solution. So let's try another one. So this is a lot like what we did on the solving problem. Notice it's basically the same problem, except this is greater than and that was equals. So we're going to be following roughly the same steps here. So you might want to have this handy to look at. So the first thing I'm going to do, I'm going to write out PEMDAS. So just like I did before, I'm going to be subtracting 2, splitting the problem, dividing by 3. So let me subtract 2 first. And remember, there's nothing to multiply or divide outside the absolute value. So I'm going to just keep going. So let's go ahead and split now. I have 3x is greater than 6. Remember, the first one stays roughly the same. And then the second one is where you flip the inequality sign and make this negative. And then I'm going to do my last step, which is to divide both sides by 3. I'm just rewriting these down here. So divide by 3. So x is greater than 2, or x is less than -2. So it kind of looks like this. 0, 2, -2. That's an open circle, even though it doesn't look like one. So basically we've got numbers greater than 2 and numbers less than -2. And there's your solution. Last 3, you've once again got very similar problems. as you did on the last notes, but I've turned them into inequalities. But you may want to have this handy so you can see what the steps were. So let's try number 9 together, but I'll let you try 8 first on your own and then come back to check it. So here's what you should have gotten on number 8. So split it first, subtract 7 from both sides. Hopefully when you split it, you remembered to flip the sign and make that negative. Then you get x is less than 3 and x is greater than negative 17. So it's basically all the numbers in between negative 17 and 3. So let's try number 9 together. So just like we did here, we're going to start off by multiplying both sides by 3. Then we're going to split it. And then split. So x minus 1. And I apologize, I didn't leave a whole lot of space there. So we're going to kind of infringe on number 10's space a little bit. Number 10 won't mind. Number 10 is nice. Remember, flip that sign, make that negative. There. And then just like we did here, we can add 1 to both sides of both equations to cancel out that minus 1. So x is greater than or equal to 37, or x is less than or equal to negative 35. So that would kind of look like these numbers. So 0, roughly in the middle-ish, 37, close dot because it does have an equal to. 35, why did I make that open? Close dot, and then shade this away. So all the numbers greater than or equal to 37, and all the numbers less than or equal to 35. Just like that. So then, with the help of your notes, and with the help of this, hint, hint, see if you can do number 10, and then come back and check it. So here's what you should have gotten. Subtract 2 from both sides, and you get negative 1. Divide by 3, oops. And then you get absolute value of x is less than or equal to negative 1/3, which can't happen. This has to be 0 or a positive number, which means it can't ever be less than or equal to negative 1/3. So there's no solution to that problem.